All right, ladies and gentlemen, we're going to continue on with this lecture. And we're going to talk about concentrations. And this is going to take a little bit because we've got different ways to express concentration. And remember, concentration is a way to describe solute per unit of solution. So we want to know the amount of solute. So usually when we talk about amount, we're talking about mass. Mass of the solute. So mass, moles. So mass of moles, this is the kind of things that we're talking about when we talk about amount of solute. And that wasn't supposed to happen. We'll get back there. There we go. Mass of moles. This is what we're looking at. Per unit of solution. So when we're talking about solution, we may look at kilograms, mass of solution, or volume, liter of solution. And with not only solution, but also solvent. So it could be either one. It could be kilogram of solvent, liter of solvent, or liter of solution or kilogram of solution. And we'll tell you which ones we're going to look at. So this is how we describe how much solute we're going to have in this solution. So first we're going to look at mole fraction. It's used to describe concentrations, usually when the solute and solvents have similar amounts. So basically we're looking in percentages. So looking anywhere from like 10 to 90% for each solute. And we're looking for moles of solute over total moles. So on the bottom is total, or the total amount. And this is X, or this is what we call chi. It's just a fancy, it's the Greek letter X. And we're talking about moles. This is how we use moles of solute over total moles. And we usually talk about multiplied by 100%. Some of the equations we're going to look at near the end of this chapter will deal with mole fraction, especially with gases. So in this chapter and the next chapter, we're going to be looking at using this for a little bit. Next is percent by mass or volume. And we're talking about usually when we have a percentage anywhere from 10 to 100 to 90%. And it's easy to quantify the mole fraction because we're looking at total mass or total volume. For example, when we're talking about salt water being 33% sodium chloride, which is high, but you get the idea. We're talking about a mass percentage. Alcohol is usually sold by volume percentage. 45% volume, or 30% volume. So we're talking about for 30 mils of ethanol to 100 mils of total volume. 50 grams of sodium chloride to 100 total grams of substance. This is what I mean by percent mass. Again, we got total on the bottom, and it has to match the solute and mass, volume and volume. So this is important for you guys to remember. Now, since the environmental field got going, you also know ppm and ppb, and this is used to describe small mass percents of a solute in small amounts. And we'll go back what that actually. Next slide will tell you what ppm and ppb actually means. But I want to make this note. In the environmental industry and health industries, part per billion is used to describe mass of a contaminant in water. And water is the key, because this note is only true in aqueous systems because the density of water is approximately 1 gram per milliliter. So this is why we can use ppm and ppb when we're talking about a mass of a solute dissolved in water. And again, we're talking about very, very small amounts, because if you look at ppm, it's milligram of solute per kilogram of sample, or microgram per gram. And then ppb, part per billion, is microgram of solute per kilogram, or nanogram per gram. So make sure you understand what these definitions mean, because they will pop up in your ALS or something like that. So this, again, this is going to be important. So next slide. Common usage in chemistry, though, excuse me, long day today, is molarity with an R. This is moles of solute over liters of solution. This is important because this our next definition has kilograms of solute, or solvent, excuse me. So moles over liters of solution. Since volume is temperature dependent, because the density is temperature dependent, when we're talking about molarity of a solution, we're usually talking about room temperature. And so, and you can try this with water. Get something like a narrow glass and mark it and fill up out 2/3 away and put a little mark on it and put it in the fridge. See if you can see the volume decrease a little bit, especially if it has a narrow neck, like some of our flasks. If you decrease the temperature, this level will go down. Not because we're losing water, mainly because is that the density increases, excuse me. The volume gets smaller. And as you heat up, the water actually becomes a little bit higher, expands a little bit as you get heated. So, well, a lot of solutions, a lot of compounds do have this effect, temperature effect. So, keep the room temperature, moles of solute is per liter of solution. Now we have molality with an L. Lowercase m is the designation, moles of solute per kilogram of solvent. And we use this to calculate physical changes of a property of a solvent. And we're talking about some of the like freezing point depression, boiling point elevation, which we're going to do at the end of this chapter. Know these definitions, because in chemistry, 1.0 m is equivalent to saying 1.0 moles per liter of solution, whereas 1.0 m is 1.0 moles of compound per kilogram of solvent. So when you ever see big M, because we're lazy, we only just use one symbol, automatically think of this. Lowercase m, think of this. And this is why I'm going to have you guys work with this and get used to it, because you need to know the difference between the two and work with the differences between the two. Very, very important. All right, last thing we're going to talk about today is dilutions. It's basically a process of reducing amount of solute by adding a solvent. And you guys have done this. Have you ever seen you get a can of concentrated orange juice in a can, it's frozen, orange juice concentrate. And what you do, they concentrate that down, they freeze it, and what you do, you put that into a pitcher and you add water. And when you add that, you get this this nice orange juice, and you can drink and stuff like that. It used to be a way to ship orange juice and keep it fresh for a very long time. So this is what we mean by dilution. You're diluting the concentrate to something that is more usable. And in chemistry, we do the same thing. So what we have is a flask, and we know we're going to take so many mils out. We'll take a volume out, say about 5 mils, and we're going to put it into another flask. Now we know the flask holds 100 mils. And when we do this and fill this, put 5 mils in here of our solution and add enough water to make 100 mils total, we have actually reduced the concentration of the material in the second solution than the first. So the moles that we take out, moles out, is equal to moles in the final. And that is important because this is how we make the dilutions, and we're going to have an equation associated with this. And then everybody calls it M1V1 is equal to M2V2. This is the equation for dilutions. And this is moles out and moles in. So total moles we take out of solution equals the total moles that we have in our final. And to do that is high concentration of 1, volume of 1 that we take out equals the moles in concentration of 2 and the volume of 2. And this is going to be important because we're going to be using this in our examples next week. So I'm going to stop here. Have a good day, folks, and we'll talk. We'll have more.